Hi everyone, welcome to my first video installment of this project that I'm currently working on. Just a bit more about myself. I've been programming and developing various applications for many years. I've been programming basically for since I was like 8 years old, so it's been like well over 30 years. A lot of different stuff. Obviously when you're 8 there's not a lot you're doing then, but as I got older through my teen years, I did a lot more game development and machine code development and all this kind of stuff. So I've been pretty deep in development in games, especially of course when I was much younger. As time went on, I moved more into healthcare and other development, regular 9-to-5 job, dealing with interfaces, stuff like that. So over time, 1 year leads to 2, 2 years lead to 3, and so on and so forth. And you lose track of time, basically. And so I've been really wanting to get back into game development. Just not too long ago, I was working with an application, Construct 2 for HTML5 development, and I really like the layout of the software. You can create your game, and you can do a lot of stuff with that. Point and click development is more like a visual programming language of sorts, so it's a really nice system. And in using it, I started to get an idea for something which is not necessarily new, but I remember a game that I played before. It was like Falling Sands, I guess, and there's other sand-based ones. And basically, you can play with sand. Each particle of the sand is a piece of matter. So I started thinking to myself, why not create a simulated world using particles, but in one which you can play, and so you're like fully immersed. And it's hard to do this in 3D. I should say, some people might say it's easier to do in 3D, but to get down to the particle level, it's a little bit more difficult. You could deal with particles and viscosities and all this stuff, and you could wrap meshes around them, but it's a lot of calculation, a lot of work, a lot of trying to figure a lot of that stuff out. It's not something I wanted to really get into just yet. It takes a lot of time to really get that right. I wanted something more simple. I wanted something that I could start with just as a proof of concept and then grow from there. Right? And then you guys can come along for the journey. And then I thought, hey, why not create a series of videos from beginning to end, showing the development of the project. Not getting into the code. I'm not going to get into the code I might touch on pieces here and there, but I just want to give a visual show on a few things just to give you an idea of what's going on and the progression of the project. For right now, I'm calling this World Simulator 2D. Now, World Simulator 2D is the project that I have currently that will simulate a world, basically in pixels, and hopefully, possibly even mix it in with some sprite bodies composed of these particles as well, and at some point with an editor, so you can animate and do different things. My vision is not just your typical like Terraria or other type of game. Yes, I know these do exist, but I'm thinking of something that, like, from my own vision, that you feel like you're on another planet, and with effects and everything else. And not just that, but I want to be able to create objects that you can find and utilize, and just have like flowing water that's natural, water, rain that comes down and sits for a while or flows into puddles and stuff like that. Like real nice effects that feel realistic. Growing trees and stuff like that, and to top it all off, the cherry on the cake, text-to-speech. And I thought, wouldn't it be great to integrate Amazon Web Services Poly system? That way, you could literally have something with you that could talk to you. So I'm thinking maybe the character in this game will just be a simple bot that kind of hovers off the ground and will talk to the player, and the player can move the bot around and explore different things. That was one idea. Or just have a character in the game with a kind of like a drone that follows him around that he can talk to instead. I'll probably do the latter one. But in any case, there's a long ways to go to get to that point. We got to get the physics right. Right? I mean, we got to get everything in place. Now, I already spent some time over the last week doing a proof of concept, getting some stuff together. Right? I have basically it only took me maybe 3 or 4 days to, actually just evenings, mostly, and last weekend, just to, throw some of this stuff together. And so I have, of course, your typical graph objects and your layers and just some typical stuff, basically starting at the engine level, right? Which engine has a bunch of worlds. The cool thing is that each world can render to a different part of the web page, so that's cool. Have a different as a matter of fact, it doesn't have to be a canvas. Right now I have a Pixie render service, so we'll use PixiJS, but I could really render to a section of the page that's like a canvas and another section of the page that's HTML, just pure DOM elements, possibly. As long as it implements render service, I could have an HTML render service and all this stuff, and I can try different renderers, so I think it would be cool to try the simulation engine with different renderers, and perhaps that could even be a cool bench. And the other thing too, which you might find interesting, I thought it might be kind of cool to try this, the physics system for getting the gravity to work between objects and different forces. I may try to use this GPU.js system to send number crunching routines to the graphics processor. Now this is cool because I know GPUs have many threads that can process many parts of given data at the same time. So if you have, for example, you wanted to process a 512 by 512 texture as input, it could process many of those texture pixels or texels, I guess. I believe the GPU.js probably uses the shader system, multiple inputs and outputs, and this basically means that they can process in parallel, multiple threads executing in the GPU, processing and number crunching the data, and that would be pretty fast, I think. I could give it an array of information for different objects and have it calculate the gravitational forces and other stuff, perhaps between objects, and offload that to the GPU as well. That'll have to be tested because I'll need to get the data back to process that, and I just hope there's a little overhead, but that could be really cool to try. But anyways, in the meantime, I don't have to deal with that just yet. I can actually just do it in here manually. I do have the physics object in here with some physics-based processing. Now, something that you might find pretty cool right here is the fact that different classes inherit from different objects, right? For example, physics object inherits from spatial, spatial inherits from graph object, but at each level, right, if I go into the super for this one, you'll find that it calls this one, and the super for this one, this calls into this one, and then of course this one, spawns off to the different children and calls update. Problem is that there's a lot of overhead calling functions. So for the engine, I have a compiler that takes an object and a function and flattens it down. Inline supercalls, scans through the system for all its types, and then flattens functions that have overridden base functions. So in this case, if I go to compile, you see this basically will go through the type and just flatten down. This actually calls another function above it I just created called inline function. So this will actually go through and compile the JavaScript and inline it in a basic sense. It doesn't have to compile everything about the JavaScript, just certain key pieces to pull out vars and so on and so forth, and it flattens it very well. I can turn that on and give a speed boost. For now, I don't turn this on actually right away, simply because I want to debug without it first. And this is kind of like something you would call in a release. So this is the main site code that sets up the engine and renders everything. Here we have the world simulator engine, and then we're basically creating a world and then configuring it to the canvas. Then we get a layer, and then we create a particle. So there's a whole bunch of particles in here. So basically this is the site setup code. And start your engines. This is called when I click the play tab on the website. So when this is called, the engine gets set up, and then the periodic table of elements. I actually do have a periodic table of elements that gets imported here. I'll get to it. Here we go. So basically, I have gotten a list of some periodic tables online somewhere. Just put them in here, imported them, and you can actually use the periodic table namespace with some of these names taken from the periodic table. You can select them, and it uses actual information in order to create different particles that at least have certain properties from these. I don't intend to, at least at this moment, try to make a realistic, perfect simulation of these, but it's kind of like a starting point to kind of get like the mass and densities of different elements that you might want to use in the game, so to speak. But and colors. There's actually color data in here apparently, for some of them anyway. And I might tweak this as well at some point, but we'll see. But anyways, this is it's just the default information again for proof of concept. And so basically this is an entire table of elements that I can just click on here and select any kind of element that I want, pop it into here. And again, this was all just whipped up in 3-4 days. Just put something together as a proof of concept. And here's the matter and velocity setup. I do have a physics loop going on here and then a render. And so I have a velocity scale because basically you don't want to jump from pixel to pixel. So basically you don't want to have a case where you have a particle here and there's another particle here, and they're both traveling so fast that they basically swap positions. And then so now this one is, this particle ends up over here, this particle ends up over here, and there's no collision between them because they miss each other. So you want to be able to say, okay, if this is going to have a velocity of, if it's, maybe, a velocity of, 4, so it's going to skip so many. What it does is it divides the velocity by the velocity scale, right? And so in this case, what it means is that you have to call this a certain number of times. So the frame rate right now is, it's 60 times a second. So divided by velocity, it means that it will calculate how many times to loop this engine update to basically jump through the iterations until you get to this point. Some people might cringe at that. Some people say, well, why can't you just calculate a line and then calculate another line and calculate another line, and where they intersect, you just kind of calculate that as a collision point and stuff like that. I thought about doing that. Calculating intersecting lines like that might be, too much. I have a grid basically, of where items are, and so when objects are in a grid, I can just simply use their Y and their X location and find out what particles are in that grid location. If I have to go, drawing lines and finding out what intersects the line, it just gets, that just might be too much algebra, too much calculations and math going on. So maybe we'll think about it. But for now, this is the way I'm doing it. And yeah, so, and the only one other thing I wanted to mention is on the world. There was one other thing I found very useful was dampening. Because I found that if you don't set a max gravitational force to dampen it, what happens basically is when gravitational objects hit that center, the explosion is immense, because the way the gravitational force is, you get two masses of a very, very small distance between each other, causes a very, very huge force, an explosive force even. If your distance was like 0.000001 or even less, and divide that into the huge masses of two objects, that just explodes it. So basically, what I did is I set this down here to 0.1, meaning that the force, if it starts to increase, would be capped, right? And so let me go ahead and run this and show you. So under play, this is the default project, by the way. And there you go. So the way I have this set up is up is positive y, down is negative y, left is negative x, and right is positive x. So think of it like a 3D world. A 3D world where the center is in the middle and there's no z-axis. So a 2D 3D world, in essence. 3D in that there will be layers. There are layers. There are multiple layers. The layers will be the actual z-coordinate in a way. There's no actual z-coordinate in the system, but for the effect. The maybe gases and water will be at the front layer, and certain other background stationary static objects would be in the back. Okay, now let me show you if I was to, for example, increase this to 10. So if I don't cap it, see what happens. And there's the velocity scale, right? Again, I have a lot of comments in here too in this code, so you'll be able to, you're using the system, you can always go through it. Oh, there you go. See what happened? Boom. They hit the center and the force just exploded. And then now they're just gone off to infinity. So if I don't cap the gravitational force, it will explode outside the system. Right? So even if I put 1 here, I think it was too much. Let me just double check that. Again, this is just a default ASP.NET Core page. I just set up Martian Worlds, and by the way, Martian Worlds is the proof of concept game for this, which may turn into a full thing. But for now, I just created a play menu. When I do run this project, at least until I update some of this is just the ASP.NET Core default page. I did not create this. I did create this tab. And there you go. And so this could be acceptable. But you see how they're getting really, really violent to that center? And now they're like way outside the screen. So I'll play with that. Maybe I might just keep it at that value, or I'll keep it at point. At least, keeping it at 0.1 keeps them inside the screen. When they hit this, they don't fly outside the screen, right? So I kind of like the way it was working with the 0.1. So I might just keep it as 0.1 here, and just go with that. And there we have it. So I think that's more than adequate, at least for now. Again, this maybe 1 is probably more accurate. Objects flying in and then slowing down and coming back in. At 0.1 force cap basically keeps them from flying outside the screen, at least for my demo purposes, because this is a game after all. This is a simulation for a game, not real life. But I want to get as close to real life as possible. So the way this is set up is that the center is sort of like where the planet would be. I don't know exactly how this might fit together. If I will have a planet that's circular, or maybe I'll have the top part of a planet that you play on. Maybe I'll just make it flat and have G going down only. But the center will always still be 0, regardless. And I'm still trying to figure that part out. For now, I just need to work on the collisions, because these particles don't actually collide with each other. So, and you notice how fast they're going. Looks like they're skipping pixels, and they kind of are. And by the way, these are actually 8x8 pixels. I'm calling these particles, world particles, or simulation world particles. These are actually made up of 8x8 pixels. That's in graphics display pixels. And this can be adjusted, so I could actually come down here and simply say I want pixel size to be 4, half the size, and there you have it. So now you have a much larger space with smaller pixels, but if you had a lot of pixels on this screen, it could be a lot of processing involved as well. So obviously if you have a lot more pixels, there's a lot more objects to process, could slow things down. I think also it may be visually hard to work on the interaction between the objects visually, so it's probably best to have the pixels slightly larger just for the initial development. By the way, the gravity doesn't affect each other yet, so that's going to be something next. And that could also be something the GPU.js system might be able to process, and just have it offload the processing of the gravitational forces applied to the objects off to the card. It would be nice if the GPU.js system could run in a thread, a web worker perhaps, but I know some browsers have a working prototype of the possible web worker canvas, but at this time it's not really that supported across the browsers. So I probably won't get into that, although I did think of using a web worker for the physics as well outside of all this, but it turns out that the GPU might be able to do this instead, so that's probably most likely what I'll do. So looks like we lost a particle here somewhere. In any case, so as you can see, like even at 0.1 cap force, like they can still fly out of the screen with enough force. They just don't shoot out to infinity because there's still enough force pulling them back. So yeah, I mean, there's obviously a lot more work to do on this. Looks like we have some asteroid flying around here now. But in any case, I just wanted to show that the real world physics are in there. At some point I envision having like an actual level. You can dig through ground. You can build your house. Yes, you can do a lot of that stuff in existing games today. I wanted to be able to build something myself. Basically, this is kind of like a learning curve in some cases for me. I have built some games in the past, but it's been so long, I want to kind of get back into it. So that's what we're doing. Just kind of getting back into the whole game of building games. And yeah, come along for the ride. Subscribe if you like what you see. If you want to see this game grow piece by piece, I'll be creating videos showing you, my progress in doing this. I may not get into the code so much, or I might. If you want me to get more to the code, you can leave some comments and some questions. I'll answer them, and we can go from there. All right, until next time.